Electrical codes often include grandfathering clauses permitting existing installations that don't meet current codes to remain, provided they don't pose a hazard. However, this isn't universally applicable. The National Electrical Code, or NEC, Section 700.12b2, mandates segregating non-emergency loads onto a separate transfer switch. The situation involves an existing generator powering both emergency and non-emergency loads through a single transfer switch, which doesn't align with current NEC standards. To determine if an existing installation meets current safety standards, it is best to consult with a qualified electrical contractor. They can evaluate the existing installation and determine if it meets current safety standards. A recommended step is to consider separating emergency and non-emergency loads. This entails installing a new transfer switch exclusively for non-emergency loads, representing the most compliant and secure method. Regarding grandfathering, if the current setup meets safety standards and presents no immediate risk, you might argue for grandfathering under the relevant electrical code. However, this is improbable for adding more non-emergency loads. While grandfathering offers some flexibility for existing setups, adding non-emergency loads to a transfer switch also serving emergency loads isn't generally advisable. The safest and most compliant strategy involves separating emergency and non-emergency loads onto distinct transfer switches. First, understand the purpose of emergency systems as defined by the NEC. Emergency systems are intended to automatically supply illumination, power, or both, to designated areas and equipment in the event of failure of the normal supply or in the event of accident to elements of a system intended to supply, distribute, and control power and illumination essential for safety to human life. These systems are crucial for life safety and must operate reliably when the normal power supply is interrupted. Secondly, consider the implications of mixing emergency and non-emergency loads. The NEC aims to ensure that emergency loads receive the highest priority during a power outage. By segregating non-emergency loads, the code minimizes the risk of these loads impacting the performance and reliability of the emergency system. This segregation is achieved through the use of separate transfer switches and distribution pathways. Thirdly, examine the specific requirements of NEC Section 700.12b2. This section explicitly states that emergency systems must have adequate capacity and rating for all loads to be served. It further clarifies that non-emergency loads, if any, must be supplied by a separate transfer switch. This requirement is not merely a suggestion but a mandatory provision to ensure the integrity of the emergency system. Fourthly, evaluate the existing installation against current code requirements. If the existing generator system combines emergency and non-emergency loads on a single transfer switch, it does not comply with the current NEC. The age of the installation is not necessarily a determining factor, as the NEC is regularly updated, and older installations may be required to be brought up to current standards when modifications or additions are made. Fifthly, consider the potential for increased risk with the addition of new non-emergency loads. Even if the existing generator has sufficient capacity to handle the new load, adding it to the existing transfer switch could compromise the emergency system. The increased load could strain the generator, reduce its reliability, and potentially delay or prevent the emergency system from operating as intended. Sixthly, explore the limitations of grandfathering clauses. While grandfathering clauses exist to allow existing installations to remain in place without meeting current code requirements, they typically do not apply when modifications or additions are made. The addition of new non-emergency loads would likely trigger the requirement to bring the entire system into compliance with the current NEC, including the separation of emergency and non-emergency loads. Seventhly, understand the role of the authority having jurisdiction, or OJ. The AHA is responsible for interpreting and enforcing the NEC within a specific jurisdiction. The AHA has the final say on whether a grandfathering exception can be granted. However, it is unlikely that the AHA would approve the addition of non-emergency loads to an existing system that does not comply with current code requirements, especially when it involves emergency systems. Eighthly, assess the costs and benefits of separating the loads. While installing a new transfer switch and separating the emergency and non-emergency loads may involve additional costs, it is the safest and most compliant approach. The benefits of this approach include increased reliability of the emergency system, reduced risk of overloading the generator, and compliance with current code requirements. Ninthly, consider the potential liability associated with non-compliance. If the generator system fails to perform as intended during an emergency due to the combined loads, the client could face significant liability. Compliance with the NEC is not only a matter of safety, but also a matter of legal responsibility. Tenthly, document all decisions and recommendations. It is essential to document all discussions with the client, the evaluation of the existing installation, and the recommendations made. This documentation can help protect against potential liability and demonstrate due diligence in addressing the issue. To elaborate on the NEC requirements, it is important to understand the different types of emergency systems and their specific requirements. The NEC defines various types of emergency systems, including those for life safety critical operations and legally required standby systems. Each type of system has specific requirements for its design, installation, and maintenance. For example, life safety systems, which are intended to protect occupants during a fire or other emergency, have more stringent requirements than legally required standby systems, which are intended to provide power to equipment that is essential for business operations. The NEC also addresses the coordination of emergency systems with other electrical systems. It requires that emergency systems be designed and installed to minimize the risk of interference with other systems and to ensure that they operate reliably when needed. This includes requirements for the separation of wiring, the use of dedicated circuits, and the coordination of overcurrent protection devices. In addition to the technical requirements, the NEC also addresses the administrative aspects of emergency systems. It requires that emergency systems be inspected and tested regularly to ensure that they are in good working order. It also requires that documentation be maintained to show that the system has been properly installed, maintained, and tested. Furthermore, when evaluating the existing installation, it is important to consider the condition of the generator and its associated equipment. The generator should be inspected to ensure that it is in good working order and that it has sufficient capacity to handle the existing and proposed loads. The transfer switch should also be inspected to ensure that it is functioning properly and that it is capable of transferring the load from the normal power source to the generator in a timely manner. The wiring and other electrical components should be inspected for signs of damage or deterioration. If any issues are identified, they should be addressed before adding any new loads to the system. Moreover, it is essential to consider the impact of the new non-emergency loads on the generator's fuel supply. The generator must have sufficient fuel capacity to operate for the required duration, even with the additional load. The fuel supply system should also be inspected to ensure that it is in good working order and that it is capable of delivering fuel to the generator at the required rate. In summary, adding non-emergency loads to an existing generator system that also serves emergency loads requires careful consideration of the NEC requirements, the condition of the existing equipment, and the potential impact on the emergency system. While grandfathering may be an option in some cases, it is generally not recommended, especially when it involves emergency systems. The safest and most compliant approach is to separate the emergency and non-emergency loads onto different transfer switches. It is essential to consult with a qualified electrical contractor and the ASHA to ensure that the installation meets all applicable requirements and that the emergency system operates reliably when needed. Before proceeding with any modifications or additions to the generator system, it is recommended to conduct a load study to determine the actual demand of the existing and proposed loads. A load study involves measuring the current and voltage of each load over a period of time to determine its average and peak demand. This information can be used to verify that the generator has sufficient capacity to handle the loads and that the wiring and other electrical components are properly sized. The load study should also consider the diversity factor of the loads. The diversity factor is the ratio of the sum of the individual peak demands to the peak demand of the entire system. This factor accounts for the fact that not all loads will be operating at their peak demand at the same time. The diversity factor can be used to reduce the required generator capacity and the size of the wiring and other electrical components. Additionally, when selecting a new transfer switch, it is important to choose a switch that is properly rated for the voltage, current, and interrupting capacity of the system. The transfer switch should also be listed by recognized testing laboratory such as Underwriters Laboratories or UL. The transfer switch should be designed to automatically transfer the load from the normal power source to the generator in the event of a power outage. It should also be equipped with a manual override feature that allows the load to be transferred manually in case of a failure of the automatic transfer mechanism. The transfer switch should be installed in a location that is readily accessible for inspection and maintenance. It should also be protected from physical damage and environmental factors such as moisture and dust. The wiring connections to the transfer switch should be made in accordance with the NEC and the manufacturer's instructions. The wiring should be properly sized and insulated to prevent overheating and electrical shock. The transfer switch should be grounded in accordance with the NEC to provide a path for fault current and to minimize the risk of electrical shock. Regular maintenance and testing of the transfer switch are essential to ensure that it operates reliably when needed. The transfer switch should be inspected regularly for signs of damage or deterioration. The wiring connections should be checked to ensure that they are tight and secure. The transfer switch should be tested periodically to verify that it transfers the load properly and that the manual override feature is functioning correctly. The results of the inspections and tests should be documented and kept on file for future reference. When considering the installation of a new transfer switch, it is also important to consider the impact on the existing electrical system. The new transfer switch may require modifications to the existing wiring, conduit, and overcurrent protection devices. The modification should be made in accordance with the NEC and the manufacturer's instructions. The modifications should be inspected and tested to ensure that they are safe and that they do not compromise the integrity of the existing electrical system. Furthermore, it is important to consider the coordination of the new transfer switch with the existing emergency system. The new transfer switch should be designed to work seamlessly with the existing generator and other emergency equipment. The transfer switch should be programmed to transfer the load automatically in the event of a power outage and to return the load to the normal power source when the power is restored. The transfer switch should also be equipped with a remote monitoring system that allows the status of the system to be monitored from a central location. This can help to identify potential problems and to ensure that the system is operating properly. Also, the process of separating emergency and non-emergency loads may involve some disruption to the existing electrical service. It is important to plan the work carefully and to minimize the downtime. The work should be scheduled to be performed during a time when the impact on the client's operations will be minimal. The client should be notified in advance of the planned outage and should be provided with a schedule of the work to be performed. The work should be performed by qualified electricians who are familiar with the NEC and the manufacturer's instructions. The electrician should be properly trained and equipped to perform the work safely and efficiently. The work area should be properly barricaded to prevent unauthorized access. The electrician should wear appropriate personal protective equipment such as safety glasses, gloves, and hard hats. The work should be inspected and tested to ensure that it is safe and that it meets all applicable requirements. The client should be provided with a written report of the work performed and the results of the inspections and tests. In addition to the technical aspects of separating emergency and non-emergency loads, it is also important to consider the legal and regulatory requirements. The installation must comply with all applicable federal, state, and local codes and regulations. The installation must be inspected and approved by the AHA before it can be placed into service. The client may need to obtain permits and licenses before the work can be performed. It is important to work with a qualified electrical contractor who is familiar with the legal and regulatory requirements in the area. The contractor can help to obtain the necessary permits and licenses and to ensure that the installation complies with all applicable requirements. The contractor can also provide guidance on the best way to separate the emergency and non-emergency loads and to ensure that the emergency system operates reliably when needed. Finally, remember that the safety and reliability of the emergency system are paramount. The decision to add non-emergency loads to an existing generator system should not be taken lightly. The decision should be based on a thorough evaluation of the existing system, the NEC requirements, and the potential impact on the emergency system. If there is any doubt about the safety or reliability of the system, it is always best to err on the side of caution and to separate the emergency and non-emergency loads onto different transfer switches. This will help to ensure that the emergency system operates reliably when needed and that the occupants of the building are protected in the event of a power outage. When considering adding non-emergency loads to a generator already serving emergency systems, remember that emergency systems are designed to prioritize life safety during power outages. Adding non-essential loads can compromise the system's reliability and potentially endanger lives. Firstly, ensure the existing generator system complies with the current NEC, specifically Section 700. This section outlines the requirements for emergency systems, including the separation of emergency and non-emergency loads. Secondly, evaluate the generator's capacity. It must be able to handle both the existing emergency loads and any proposed non-emergency loads without compromising its performance. A load study is crucial to determine the actual demand. Thirdly, assess the transfer switch. If it's a single transfer switch serving both types of loads, it violates the current NEC. A separate transfer switch is required for non-emergency loads. Fourthly, understand the grandfathering clause limitations. While existing installations might be grandfathered, adding new loads typically requires bringing the entire system up to current code. Fifthly, consult with the local AHJ. They have the final say on code interpretations and whether grandfathering applies in this specific situation. Sixthly, weigh the risks and benefits. While adding non-emergency loads might seem cost-effective initially, the potential risks to the emergency system and the associated liability outweigh the benefits. Seventhly, prioritize safety and compliance. The safest and most compliant approach is to install a separate transfer switch and isolate the non-emergency loads. This ensures the emergency system functions reliably during critical situations. Eighthly, document all decisions and consultations. Maintain a record of discussions with the client, the OJ, and any electrical contractors involved. Ninthly, consider future expansion. When designing the new system, plan for potential future load growth to avoid similar issues later. Tenthly, be prepared to explain the code requirements and the rationale behind them to the client. Emphasize the importance of safety and compliance over cost savings. Remember that prioritizing safety and adhering to the NEC are paramount when dealing with emergency power systems. Compromising the emergency system's reliability can have serious consequences. Consider a building with critical life support systems. If non-emergency loads are connected to the same generator and transfer switch, a power outage could overload the system, causing it to fail. This could have devastating consequences for patients relying on those life support systems. Alternatively, in a high-rise building, emergency lighting and fire pumps are essential for safe evacuation during a fire. If the generator is overloaded with non-emergency loads, these critical systems might not function properly, hindering evacuation efforts and endangering lives. These scenarios highlight the importance of adhering to the NEC and separating emergency and non-emergency loads. It's not just about code compliance, it's about ensuring the safety and well-being of building occupants. When discussing this with the client, emphasize these potential consequences. Explain that the cost of compliance is a small price to pay compared to the potential costs of a system failure during an emergency. Frame the discussion in terms of risk mitigation and responsible building management. Show them that adhering to the code is not just a regulatory burden, but a fundamental aspect of ensuring a safe and reliable environment. In addition, be prepared to answer their questions and address their concerns. They might be worried about the cost of installing a new transfer switch or the disruption to their operations. Provide them with realistic cost estimates and timelines. Explain the benefits of the new system, such as increased reliability, reduced risk, and compliance with current codes. Reassure them that the work will be performed by qualified professionals and that every effort will be made to minimize disruption. Finally, remember that you are acting as a trusted advisor. Your role is to provide them with the best possible advice and to help them make informed decisions. Even if they are initially resistant to the idea of separating the loads, your expertise and guidance can help them understand the importance of safety and compliance.